Okay, thank you very much introduction. So today my topic is how to say the EM analysis. So under practical scenario, so the many practical guys in here. So probably sometimes the explanation is very, very complex. So my English is not good. The GPT-4 is supported my presentation. So some part is supported. Okay. Okay. In this presentation, what is the practical scenario? In this presentation is not general. In this presentation, a practical attack scenario 1 is using electromagnetic wave to acquire information from outside the device without embedding the device. Outside the device is one practical scenario. So probably you know there are many the EM analysis paper was appeared in the crypto, crypto community, and the practical security community that appeared. One the famous paper is EM side channels. This is the author is Pankaji and Bruce Archambault. He is a very, very famous EMC engineer. So this paper target is SSL accelerator. So and the algorithm target is RSA. So that they catch the EM wave from probably 5 or 6 meters at a distance. They can they can extract the secret key from EM wave. Oh, excuse me. And the next one is Jenkins. This is Jenkins' papers. The test 2014. He grabs the PC. He extracts information from the laptop PC. This is a practical outside the device. Third one. The example is a target is different from the cryptographic device. This is the target is a keyboard. The EPFL team they showed the EM leakage from the keyboard. This is also outside the device. They observed the EM waves. This paper also focused on the EM measurement distance. Probably you know that this building. Building is K. Rubin. This also is how to say PhD, a past PhD student in the K. Rubin. He showed the how to say the attack limitation of tempest. This paper, the target is a display. Attack distance is 80 meters. Oh, same family name. Oh, is cousin or brother? No, okay. Okay, he's not COSIC. He's, I don't know. Okay. This is, how to say, our paper. The target is the tablet. We get the secret information from the tablet from the EM. This is how to say in the public space. This is an attack scenario. So I show you the how to say the demo. Similar. Okay, this is a demo. Attack the tablet device. Okay, this is a TV antenna. This is a USRP. This is a normal PC. We connected each other. So we observed the EM emanation from the tablet, and then we analyze the measured EM. Finally, we get the display screen image in real time. In this attack, we can observe the input key by using software keyboard like this. Okay. 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 Next, I will explain the practical scenario 2. Probably this is how to say many people did not consider this kind of point. This is how to say the important. Not important. This is scenario 2. Okay. I use GPT for the explanation.
In the previous studies mentioned, it's explained that information can be obtained through electromagnetic waves. However, there isn't enough discussion about the environment in which these measurements were taken. Here, environment refers to the electromagnetic environment, which greatly affects the intensity and frequency spectrum of the electromagnetic waves that are emitted.
Okay,
From the perspective of electromagnetic information leakage, this ultimately impacts the ability to capture information. Therefore, in this talk, I will also explain how the ability to capture leaked information changes when the electromagnetic environment changes.
Okay, can you imagine electromagnetic environment if you measured EM from the device? Okay, from here, this is the today's topic. The first, I will show you the mechanism of leakage, EM wave containing outside equipment. The second one, the third, the fourth. This is my today's talk topic. Okay, first, this is mechanism of EM leakage. This is how to say is very very simple the formula. So the source and the path and antenna is essential factor of EM emanation. Please remember this each factors. Okay. Next one is mechanism of EM information leakage through EM waves. This explanation is a little bit complex, so the GPT-4 supported me.
This figure shows how electromagnetic radiation occurs through the product of source, path, and antenna. A shows the time domain waveform of the target signal, source. B shows the frequency domain waveform of the target signal, source. C represents the frequency characteristics of the path and antenna. D represents the time domain waveform of the electromagnetic waves radiated outside the device. What we need to pay attention to here is that strong radiation occurs when the frequency characteristics of the source match the frequency characteristics of the path and antenna. Conversely, if the frequency characteristics of the source do not match those of the path and antenna, strong radiation will not occur, even if the amplitude of the source is large. Additionally, from another perspective, the path and antenna could be considered as frequency filters for the source.
Okay, when we consider the EM emanation, the frequency domain is important. So from here, I mainly focus on the frequency domain, the EM leakage. Okay, first, I show you to explain the EM leakage source. Probably you know how to say the measure EM leakage source. The one of the most measured the EM leakage source is a cryptographic device. This is the side channel signal. This is one how to say the popular source of EM leakage. The second one is not crypto. Not crypto. There are many devices. The I/O devices, for example, the keyboard. The I/O device, and I/O device means the keyboard and the display and the sound device. If attacker gets this kind of EM emanation, they can information immediately. This is a different, how to say, different point from the cryptographic device. This is how to say other sources, the very very popular EM leakage source, display signal. This is sometimes we say this attack tempest. The tempest is a leakage sources display. This kind of signal is leakage source. Okay. Next is a path, a coupling path. What is coupling path? Okay, this is design data of Sasebo G. This is a layout data. There are many transmission lines. So designer, in this case is Daisuke or Makoto or some researcher, how to say, they designed these patterns. The designer plan a device with ideal current flow along the wire. Okay, current flow each wires don't how to say this point is how to say difficult to keep. In the real the layout. This is a layout data of the Sasebo G2. Okay. From here, 2 pages. How to say, the explanation is a little bit complex, so the GPT-4 is supported me.
To demonstrate an example where internal electrical signals of a device do not flow along the lines, let's discuss a specific device as an example. What is shown here is the layout pattern of Sasebo. You can see that numerous transmission lines are laid out across the circuit board.
Okay. Next is the EM simulation of this layout data. How the current flow is occur in the real device.
This animation shows how the side channel information generated during the operation of the cryptographic core spreads throughout the circuit board. The side channel information is propagated even to wires that are not directly connected to the cryptographic core. Such unintended propagation is caused by the coupling path.
Okay. The coupling based on the, how to say, the 2 categories. Coupling the mechanism is roughly divided 2 categories. One is capacitive coupling, and the other is inductive coupling. Capacitive coupling is heavily depending on the electric field. The inductive coupling is depending on the magnetic field. These 2 coupling paths is how to say, they leak the signal to other transmission line. So this is how to say, the main reason, the main factor of coupling path. Okay. Third one is antenna. Antenna is not antenna. In this case, antenna is unintentional antenna. What is unintentional antenna? This is an example of the unintentional antenna. For examples, probably you can imagine this PC are connected many wires. These wires behave antenna. This cable is not, in general, this cable is not antenna, but sometimes this cable behave antenna. We call this kind of antenna unintentional antenna. This kind of structure also behave antenna. For example, laptop CCs and laptop LCD display. This part is constructed by metal, so this structure behave unintentional antenna. So the PCB and cases and the ground wire, this structure is also behave antenna. There are many unintentional antenna inside the PC and the electrical devices. So this is this antenna emitted in an EM wave finally. The loop antenna is also behave an antenna. The typical the loop antenna is how to say, around IC. This is a metal part. This part is also behave an antenna. As a loop antenna is this structure. The 2 IC is connected to signal line and ground line. This structure is also behave loop antenna. That we can find many the loop antenna and dipole antenna inside the device. This structure behave unintentional antenna. Okay, the next slide, I show you the actual example of effect of EM environment. Okay, today I focus on the 2 EM environment. One is length of lines are connected to the device. For example, this kind of device, this kind of line, the length of this kind of line. The second factor is the size of device. There are many the size. So if size is changed, cryptographic core or IC is same, but the size is changed, what kind of effect is appeared in the EM leakage? This is the two factors of today. I focus on the 2 factors. Okay. The first, in this example, leakage source are the leakage source, I focus on the IAS side channel signal. This is a leakage signal. This is a frequency spectrum. Okay, clock frequency is 24 megahertz. This is the typical side channel leakage signal. Next, we check the frequency spectrum. This previous slide, I showed you the time domain signal. This is a frequency domain signal. This is the harmonic. We can observe the many harmonic in frequency domain. This is a target device of this explanation. This is how to say a model board. Okay, probably this this kind of experiment, probably you're not familiar with this. So I praise explanation.
Next, I'll explain the target device used in the experiment. The target device utilizes a model circuit board that allows for the modification of only those parameters we wish to study in relation to leakage. Side channel information is applied between VDD and ground on this board. The side channel information leaking from the device is measured on the connected cables. When side channel information is measured on the connected cables, the cables may act as antennas and potentially radiate the information to distant locations. However, for the sake of reproducibility, measurements at a distance are not conducted here. Instead, only the antenna currents on the connected cables are measured.
Okay, in this experiment, we focus on this model board. Okay, we changed the physical parameters. We prepared the 4-length cables. The first experiment, we fixed board size. Board size is fixed. We change only the attached line. The second explanation is we fix the transmission line, attached line. We change the board size. Okay. This is how to say a measurement setup for frequency characteristics of path and antenna. Source is the same, but we change the board size and attached line. Frequency characteristic of path and antenna is changed. We can measure this kind of characteristic by using the model board. Input signal is 1 volt, but output voltages change heavily depending on the path and antenna characteristics. Okay, first experiment impact of the length of line connected the device on the side channel information. Okay.
The length of the connected wires has on the leakage of side channel information. In this experiment, we use 4 cables of different lengths. The same signal is used as the source in each experiment. When connecting the 4 cables to the model board, it becomes apparent that the frequency characteristics of the path and antenna differ. As the length of the connecting cable increases, the observed peaks in the frequency characteristics of the path and antenna shift to lower frequencies. This is thought to be because the longer the cable, the longer the wavelength that resonates, resulting in lower frequencies. Therefore, the frequency characteristics of the side channel information observed outside the device are influenced by the frequency characteristics of the source, path, and antenna, and vary with each connecting wire. Similarly, the waveform in the time domain also changes significantly.
Okay, in this experiment, source is same, but we change only transmission attached line length of attached line. But finally, time domain signal is drastically changed. How is side channel analysis? Okay, this is a result of the CMA result.
Next, we present the results of correlation electromagnetic analysis on the side channel information observed outside the device. It is found that when a 50 centimeters long wire is connected to the device, in comparison to other lengths, the secret key cannot be extracted. This suggests that in the 50 centimeter case, the frequency band containing secret key information is suppressed due to the frequency characteristics of the path and antenna.
Okay, in this experiment, the GPT-4 already explained this case is we cannot extract secret key because how to say is probably this frequency included secret information. Frequency characteristic of path and antenna is changed. This characteristic behaves filtered. So finally, the signal to noise ratio is decreasing, so it's difficult to extract secret information in this case. Okay, next example, we change board size.
When the size of the board is changed, the frequency characteristics of the path and antenna do not vary significantly in each case, but the attenuation rate at each frequency differs greatly. From this experiment, it is observed that the larger the size of the circuit board, the higher the attenuation rate. Based on this characteristic, as the size of the circuit board increases, the amplitude of the observed side channel information decreases. This feature is observed in both time domain and frequency domain side channel information.
Okay, a time domain signal is also changed. Okay, this is the effect of board size.
The results of correlation electromagnetic analysis on the side channel information observed when changing the size of the circuit board indicate that the larger the board size, the more difficult it becomes to extract the secret key. This is thought to be because as the size of the circuit board increases, the amplitude of the observed side channel information decreases, leading to a lower signal-to-noise ratio.
Okay, in this case, board size is the large. The signal is decreasing, so it's difficult to extract secret information. Okay, let's move on to actual. Is not actual, but is not model board. We focus on the susceptible G. We can change the transmission attached length. In this experiment, we change the power line length. Okay.
Finally, when changing the usage environment using boards other than the model board, we examine the impact of these changes on leaked electromagnetic information.
Okay.
Devices, changing the size of the circuit board is difficult, so here we vary the length of the power lines. Similar to the experiments with the model board, it is observed that changing the length of the connected lines alters the ease of extracting the secret key. However, the impact of each line length differs from that observed with the model board. This difference is thought to be due to the influence of electrical components installed in the actual devices and lines connected other than the power lines, affecting the frequency characteristics of the path and antenna.
Okay, in this experiment, we focus on the cryptographic device, but the tempest and the keyboard and the displays also, we should pay attention to what kind of length, what kind of cable is connected to the device. This kind of effect is very large. So the previous paper does not mention to this kind of point. If cable length is changed, leakage is changed. So this kind of frequency characteristic is affect to the leakage intensity and the frequency characteristics. So if you had measured the emanation from the target device, please pay attention to this kind of factor. So next one is okay. Let's move on to next topic is passive measurement of leaked EM waves. Okay, this probably you know that we have two leakage paths. The one is radiated emission. This is radiated to the free space. The conducted emission go through the metal cable. We have two leakage paths. How do we decide which leakage path is better for the measurement? Next, okay. This is how to say the typical measurement style of the radiated emission and its conducted emission. If we measure the radiated emission, we use the antenna. In this experiment, we use Yagi antenna. So we received EM leakage measured antenna, and we connected to the receiver. And after that, after received the signal, we applied the signal processing technique. The conducted emission, we put the current probe on the cable. The current probe pick up the leakage signal. This is different between the conducted emission and the radiated emission. Okay, and next, the impact of antenna is also important. So this is a two antenna. Log periodic antenna is TB antenna. This TB antenna is very, very cheap. But this log periodic antenna is very, very expensive. But in this experiment is how to say that? This example target is a display, which result is clear. This part is clear. TV antenna is how to say is customized special frequency. Sometimes cheap antenna is better than the expensive antenna. Please consider which frequency is leakage frequency. In this example, and polarization is also important. So antenna is how to say sometimes black magic. So, but always not expensive antenna is good. This is how to say please consider to the leakage frequency. Based on this knowledge, please select the receive antenna. Okay, the next one is a last topic. This topic is mainly focused on the active measurement. From until now, I mainly focus on the passive measurement. From this, I mainly focus on the active measurement. Okay, this is a background of this explanation. Okay, I praise explanation by ChatGPT.
Until now, the devices we targeted could have their information acquired through passive electromagnetic measurements. However, with some devices, the amplitude of the source might be too small, or the frequency characteristics of the source might not match those of the path or antenna, resulting in only weak radiation. Such devices have traditionally been considered outside the threat of passive EM attacks.
Okay, this is out of scope of passive attack. From this, we mainly focus on this kind of device. Okay, this is attack strategy of active measurement. First, we irradiate EM wave to target device, and then backscattering is occur. So, and then we observe the backscattering. Finally, we get the secret information. This is a flow of active attacks. Okay, in this experiment, target is I/O devices. I/O device means a keyboard and the display is not crypto device. Crypto device is not a target in this attack. In our context. Okay, I praise the explanation.
In the acquisition of information through active electromagnetic wave irradiation, the attacker propagates electromagnetic waves they have emitted through unintended antennas of a device to the target IC. The propagated electromagnetic waves reach the IC's output buffer, and depending on the state of the output buffer, different circuits operate, generating echoes with different amplitudes. Afterwards, these echoes are temporally synthesized and radiated outside the device, following the reverse path of the propagated electromagnetic waves. The electromagnetic waves reflected from the device can be considered as amplitude modulated waves, using the irradiated electromagnetic waves as the carrier wave. By demodulating the amplitude after reception, the transmitted information from the IC leaks. The information that can be obtained with this method is limited to that which involves switching in the IC's input and output circuits during information processing.
Okay, this is how to say the attack flow of the active EM measurement. Okay, I show you the concrete example of active EM attacks. In this experiment, we mainly that our target is UART transmission signal. That we connected to device. We prepared two devices and we connected a transmission line each other. We set the TX and RX antenna. We irradiate the signal to the UART module. Experimental setup here, and irradiation frequency is this frequency. This is amateur radio band. Okay, we changed the irradiate intensity. Receive gains here. In this case. Okay, this is a result of backscattering signal. This is the original signal. This is evaluation result 1 meter. This is 3 meter. We can decode the original signal. But if we irradiate the signal, we cannot observe the leakage EM signal. Okay, this is the final movie of our experiment. This example target is a keyboard. We irradiate the EM signal and we pick up the key input signal. I show you directly. Okay, this is a TX and RX antenna. This is a target keyboard connected to the PC. This is attack distance is 3 meters. That we can control the attack distance. Depending on the irradiate power. This is a signal generator and the software-defined radio. This is an amplifier. Many power is required this attack. So there is no leakage. Okay, we start to inject. Injection intensity is 20 dB. Injection start, we can see the leakage signal from the keyboard. Attack intensity change, we can observe the more clear transmission signal. Okay, this is a demo. Okay, this is the summary of today's my talk. The first part I focus on the how to say the EM environment effect, and the next topic is I mainly focus on the how to say the what kind of leakage path should be we focused, the conducted emission or radiated emission. And the last part, I focus on the active EM analysis. In conventional studies, some weak leakage devices out scope of the attack. But the active attack, can cause leakage from this kind of weak leakage device. Today's I conclude my talk like this. If you are interested in the today's talk, the one the topic is already published. This paper is this paper is mainly focused on the electromagnetic environment effect to the EM leakage signal. Next one is active EM analysis. We called echo tempest. If you are interested in please check these papers. Thank you very much for your kind attention.